Okay, so we're going to be solving logarithms again today. Okay, so there's going to be multi-processes that we're going to use. So let's look at the first one. So as soon as we see a log on both sides, the first thing we're going to check is to see if they have the same base. Since they have the same base, this log here and that log there, they have the same base, we can use the one-to-one property. Basically, the one-to-one property says if this and this are equal, then for this statement to be true, that this has to be equal to that. So the one-to-one property says that we can rewrite it that way and say that basically we're looking to see where 9a plus 2 is equal to a squared plus 16. Because when that statement's true, then the rest of it has to be true. And now we're basically back at an Algebra 1 problem. Okay, so we're going to move everything over to make it equal to 0. So I'm going to subtract 9a, subtract 2, subtract 9a, subtract 2. And I'm doing it that way so that my a squared stays positive. So I get 0 equals a squared minus 9a plus 14. Now basically we're doing trinomial factoring. So this is going to factor in 2 with a and a. Factors of 14 are 1 and 14 and 2 and 7. Since this is a positive, this 9 is a sum, so which add up to 9, 2 and 7. And since this is positive and this is negative, that means both of these have to be negative. So my solutions are a equals 2 and a equals 7. Now, we should always double check to make sure that these numbers, these solutions, that when we plug them back into our logarithm are accurate. Because if we plug in 2 or we plug in 7 into our original equations and either of them give me a negative inside my log, those solutions will not be valid because you cannot take the log of a negative number. Okay, but you can see when I plug in 2 or 7, either one of these, it's positive, so they are both, in fact, solutions. Okay, so number 2. Now, number 2 is tricky because normally when we see the exponential, we straight go to taking the log, okay? But in this case, if you start and take the natural log of both sides like this, first thing is you're taking the natural log of 0, which causes all sorts of problems. But even if you move this 16 to the other side and you just deal with the natural log of these two things, since both of them have a power, and this is subtraction here, we cannot use it to move the natural log or the power out of the exponent. So this normally we would take the natural log, but it's not going to help us there. But I can see that I have a trinomial. So I'm going to try something that we don't often use, but is definitely very helpful in some situations. So the first thing I'm going to do is say that, okay, well, technically this first term can be written this way, as e to the x to the second power. Because when you take a power to a power, you multiply. So that means that's why you get 2x here. So I'm going to change that and rewrite, and you start seeing a pattern emerge, okay? Because this is e to the x squared, and this is e to the x, and this doesn't have an e to the x. I'm going to use factoring by substitution. So basically what I'm going to do is I'm going to say u is e to the x. And by doing so, I'm then going to use this u to rewrite my equation because I have an e to the x here and an e to the x here. So I'm going to rewrite this as u squared, because this right here is my u and this is my u. So this is u squared minus 8u plus 16 equals 0. And what I've done is I've rewritten it without the exponential. And you can see all of a sudden we're now back to where we were in the last problem, where we have a trinomial and we can do trinomial factoring. And it makes it a whole lot easier dealing with just u than an e to the x. So u squared factors at u and u. 16 is 1 and 16, 2 and 8, 4 and 4. Well, again, this is positive, this is negative, so this 8 is a sum. Which one adds up to 8? That would be 4 and 4. Since this is positive and negative, both of them are therefore negative. So now what we have to do is when we're done factoring, we have to plug back in our u, which we know is e to the x. And now we can solve each one of these. Well, the same thing, so we just have to solve one of them. So e to the x minus 4 equals 0. So e to the x equals 4. And you can either take the natural log of both sides, or you can change it to its log form. Either way, you're going to get x equals the natural log of 4. And that is your solution. And you can plug in a calculator and it'll give you a number, but that is the answer. Okay. So this one, we use that factoring by substitution to make it easier. Now, when you see this, it probably won't have to do it explicitly like that. You can think of it that way, but it's much easier to do it so that you can deal with that with just using it than e to the x. And that's what substitution really helps with, is just to kind of make it less busy. Okay. All right, so the next one. In this one, unlike the first one, we only have a log on one side. On the first one, we had logs on both sides, so we could actually use the one-to-one property. But on this one, since we only have one logarithm, that's cluing me in to the fact that I'm probably going to solve for one log and change it to its exponential form to solve this. Okay, so that's what we're going to do. We're going to get this log by itself. So we're going to subtract 2, we get 7, log base 11, 3m minus 8 equals 14. Now, some people would either change this, use the power property and move it to the power here, but that's going to make things really terrible for you, because then when you change it to its exponential form, you're going to have 11 to the 14th power equals this to the 7th. And I really don't want to sit here and take 3m minus 8 times 3m minus 8 times 3m to 7 times. So let's keep it simple and just divide both sides by 7. And now we've got log base 11 of 3m minus 8 equals 2, which makes things much easier. Now we change it to the exponential form by taking 11 to the second power, equaling that. So we get 11 squared equals 3m minus 8. We all know that 11 squared is 121 equals 3m minus 8. Add 8, add 8. So 129 equals 3m divided by 3. Now there's a trick when dividing numbers by 3. If you add up the digits and the number you're dividing by 3, if it's divisible by 3, the whole thing is divisible by 3. So 1 plus 2 plus 9, that's 12. Since 12 is a factor of 3, this is divisible by 3. And when you divide it, you get 43. M is 43. And again, plug it back in. 3 times 43 is positive, minus 8 is still positive, so that solution does work. Okay, so always double check your solutions. So we've worked through a bunch of different ways of doing it. The first one, we used the one-to-one with 2 logs on one side. This one we factored first, but then ended up using the exponential to logarithms, or taking the log of both sides. This one, we had a log and we changed it to its exponential form. So the last one, okay, the last one, you really have to kind of see it. So 10,000, this number right here, 10,000, that's really 10 to some power. Like in science, you learn significant digits, and when you do that, you have like 4.0 times 10 to the 4th power, and that just basically means you move zeros. Well, this is 10 to the 4th power. 10,000 is 10 to the 4th power. 10 times 10 times 10 times 10. So I rewrote it that way because I'm seeing that this one right here is base 10. If I can get both sides as 10 to some power, I can use the one-to-one property and make my life way easier. Okay, so that's the first thing I do, is I change 10,000 10 to the 4th. Then I use this equation that we've talked about before. X to the negative n is equal to 1 over x to the n. So if you have something to the n power down here, you can move it to the top by making the exponent negative. So that's what I'm going to do right here. I'm going to make this 10 to the negative 4 power. and then this side stays 10 to the 8n minus 6 power. So now I can actually use one-to-one functions because my bases are the same. So if my base is the same, that means this has to be equal to that for this statement to be true. So that means that 8n minus 6 has to be equal to -4. So you add 6 to both sides, you get 8n equals 2. Divide both sides by 8, so you get n equals 1/4. And that's my solution. Okay, and I don't have to worry about this one being a solution or not because we're not dealing with logarithms, we're dealing with the exponential. Now, you could have on this problem, if you wanted to, you could have taken the log of both sides. Like if you had taken log base 10 of 10, 8n minus 6 equals the log of 1 over 10,000. But even if you had done that, you would have gotten 8n minus 6 equals this. You still would have had to change this to deal with this. 10 to what power gives me 1 over 10,000? Well, that's still going to be -4. So you're still going to have to either evaluate that log or change it to the 10 to -4 power. Okay, and it still gets you basically to right here. So why not just use the one-to-one property to help you? Okay, so there's 4 different styles of solving log and exponentials.